Hey guys, what is up and welcome back to another video. This is Sukesh Education guys, so do make sure to subscribe to my channel. So today guys, we're going to be looking at elements, compounds and mixtures part 2. So this is the part 2 of my video series on the topic elements, compounds and mixtures. So do make sure to subscribe and enjoy this video guys. So we're looking back at the periodic table, guys. So, as you know, there are 118 periodic elements in our universe, and 98 of them are naturally occurring elements. So, 98 means until californium, they're naturally occurring. And from then, it's all artificial or synthetic. So, these are made in laboratories, guys. So the periodic table is just a list of elements from the lightest, which is hydrogen, to the heaviest, which is oxygen. So this is just the list, guys. Then scientists, this is ordered in this way because scientists can then understand the physical and chemical properties of each elements, guys. So if you take aluminium, right? Scientists can analyze because it's 13th in the row. It means somewhere in the middle and stuff like that, guys. So each element has a name and a chemical symbol. So as you can see, hydrogen has its name and its chemical symbol is H. So now let's look about the chemical symbol. The same set of chemical symbols used by scientists all across the world. And why is this? This is because it makes their communication more easier and accurate. So that's the main reason, guys, because when scientists are there, they don't read stuff in their same language. Like if you're Chinese, you might read the periodic table in your Chinese language. But all the symbols are the same so that scientists can understand each other. So this chemical symbol, right guys, it comes directly from its name. So for example, we have calcium, which is Ca. So calcium Ca. And then we have carbon, which is C. So for calcium, right, it's first two letters, and then for carbon, it's the first letter. And magnesium's Mg, guys. But you might be thinking, some elements do not appear to its name. So for example, if you look at sodium and potassium, they both have a K and an Na. Like, how does this make sense? Because there's no K in the word or Na. But this is because, guys, periodic table was first written in Latin and all the elements were translated to English. So some of the elements were just left in their Latin symbol. So for potassium, right guys, the Latin name for potassium is kalium. And the Latin name for sodium is natrium. So natrium. So that's where the symbols come. So understanding this logic will make it easier for you to memorize the elements, guys. Then these elements, right guys, they're usually made from one or two letters, as you've seen. So the first letter is uppercase and the second letter is lowercase. Upper and lower. So that's the form, guys. So if you just write N and then a capital A, it's wrong. You need to write the first letter uppercase and second letter lowercase, guys. So then looking at the last 6 elements, right guys, they've been given 3 names. So it wasn't mentioned in the chart, but 118, from 112 to 18, they have 3 letters, right guys, like U, U, O. And why is this? This is because they're all radioactive elements, meaning that they have not been proved to exist. So once they've been proved that they're actually there, or with evidence, then they will receive their 2-letter form, guys. So that's what this means. Then let's look at atoms in elements. So this is another main part, guys. So elements are made up of just one type of atom, right? However, atoms in elements can be arranged in different ways to make different types. So like a single atom, just one atom, right? Substances with that are called monatomic elements. Then clusters of atoms, meaning 2 or more atoms, bonded together are called molecules. And large grid-like structures are called lattices. So you can see here, this is a monatomic element. This is molecules. These are molecules. And this one, right guys? These are lattices. Huge grid-like structures. So, looking at monatomic elements mainly consist of noble gases. So, monatomic elements are an element that consists of just one type of atom. So, these are known as monatomic, right guys? So, these elements here, right guys, they do not mix into each other. They're non-metallic elements. So, once again, let me recall them for you. The elements are helium, neon, argon, krypton, xenon, and then there's one more element that's missing here. It's radon. So guys, then also helium is used in bubbles, right? And why can it fly? Helium is less denser than air. That's why it can float up. Now let's look at molecular elements. Molecular elements are clusters of two or more atoms bonded closely together. So most non-metallic elements are made up of molecules. So most of the non-metallic elements. For example, N2, right? So nitrogen to the power 2. So now oxygen, right guys? Here, oxygen. Oxygen's O2, right? So an oxygen molecule has two oxygen atoms in it. So one nitrogen molecule has two nitrogen atoms inside it. Then also looking at a hydrogen atom, a nitrogen molecule has two hydrogen atoms inside it, and a chlorine atom has two chlorine atoms inside it, guys. Now when you look at phosphorus, right guys, phosphorus has four atoms to make its structure. So this is phosphorus, it has 4. That's why it's called P4. And then we have sulfur. Sulfur is made up of 6 sulfur atoms. To make sulfur, you need 6 atoms. And then we have carbon, right guys? Carbon is very special because carbon, this element, can form very large molecules of almost up to any size. The most famous one is the Buckyball. So this is an image of the Buckyball, guys. So this has 60 carbon atoms arranged in the shape of a soccer ball. So what's the formula for this? C60, guys, because it's carbon atoms and there are 60 of those. Yeah. Now let's look at elements in lattices. So elements in lattices are large grid-like structures that repeat the same arrangement of atoms over and over again. So that's the definition. And you can see it for yourself, right guys? You can simulate. So this element, it's really large, right guys? Also, you can see there's only 2 colors. So it's repeating its atoms over and over again to make its structure. So you can see here green, purple, green, purple. So it's just repeating it over and over again to make its substance. So all metallic objects form crystal lattices. Few non-metallic elements also can form crystal lattices, guys. So this example, right guys, this thing, it's an example, a real life example for crystal lattice. So you can see how the same pattern is arranged over and over again to make this beautiful steel, something in the steel, guys. So I really like this. So guys, that marks the end of our part 2 video. So thank you for watching. Do make sure to like and subscribe to my YouTube channel, guys. So thanks for watching. Thanks for watching, guys.